Hello, welcome to the chapter on conic sections. We're going to be looking at parabolas today. A conic section is when a plane intersects a cone or a double mapped cone to create one of these shapes you see at the bottom here. We will specifically be looking at parabolas today, which is something that we've already looked at. We've seen parabolas with the equation in vertex form. We've also seen parabolas with the equation in standard form as well. Today we're going to look at the definition of a parabola and create a new equation that we'll work with in this section. So let's look at the definition. It says a parabola is the set of all points in a plane that are equidistant from a fixed line, the directrix, and a fixed point, the focus, that is not on the line. So a parabola has a line in back of it called a directrix and a point in the cup of the parabola called the focus. And what the definition says here is that if you go from the focus to any point on the parabola, and then from that point on the parabola you go to the directrix and you do create a 90-degree angle there, then these two line segments from the directrix to the parabola and from the parabola to the focus, these two line segments are equal to each other. So you could go to any point on the parabola. If I decided to go here from the focus and then directly to the directrix, then once again, these two line segments would be equal to each other. So the way to come up with this new equation that we're going to be working with today is pretty easy. If you place the parabola on the xy system with the vertex at the origin, we create two distances that are equal to each other, from the directrix to the parabola and from the focus to the parabola. These two distances are equal to each other, and we can use the distance formula to come up with this new equation we have here at the very bottom. So we have a new equation that has this variable p in it, and p will tell us many things about the parabola. It tells us how wide the parabola is. It tells us the distance from the vertex to the focus, the distance from the vertex to the directrix. That's the p-value. Let's go to the next page here. We're going to look at parabolas on their side and parabolas up and down. So on the left here, we have a parabola on its side, and when we're working with a parabola that is on its side, we're going to be dealing with y squared. When we're dealing with a parabola that is either faced up or down, then we're dealing with the x squared. Okay? A couple other things. If the p-value is positive, then the parabola is going to face towards the positive x direction. Also, if the p-value is positive, it will face towards the positive y direction. If the p-value is negative, however, the parabola will face towards the negative x direction. And if it's a parabola that is with the x squared, then you're going to see a parabola that faces towards the negative y direction if the p-value is negative. So once again, the p-value tells us the distance from the vertex to the focus, from the vertex to the directrix. It also tells us the focal width of the parabola. The focal width is literally the distance from one end of the parabola to the other end of the parabola, a line segment that goes through the focus point. This is known as the focal width. So focal width goes through the focus from one end of the parabola to the other end of the parabola. It's the line segment that goes through the focus. And this is found by taking the absolute value of 4 times p. So let's go ahead and start working with parabolas that are centered at the origin. For this particular problem here, y squared equals negative 8x. We want to find the vertex focus, the focal width, and the directrix, and then graph. So, excuse me. First of all, the vertex, that's really easy. The vertex for this type of parabola is at 0, 0. And we want to figure out what the focus and the focal width and the directrix are. In order to do that, we need to figure out what the p-value is equal to. And so what I want to do to figure out the p-value, I want to set this equation, I want to compare this equation that was given to the general form of the equation of a parabola that's on its side. So we have y squared equals 4px. And so right now, I want to figure out the p-value by comparing these two equations. I see that I have a negative 8 in front of the x, and I have, for the general form of a parabola on its side, the 4p next to the x. So to find out the p-value, simply need to take negative 8 and set it equal to 4p, and then solve for p. So that tells me that p then is equal to negative 2. So I have a negative p-value, and because I'm dealing with y squared, that tells me that I'm going to have a parabola that's on its side faced towards the negative x direction. Okay, so let's go ahead and figure out the focus and the focal width and the directrix. I know that because I have a p-value of negative 2, I'm going to go 2 spaces to the left here to find the focus point. The focus point is at negative 2, 0. Remember that the focus is in the cup of the parabola each time. The directrix is the line in back of the vertex here. And so the directrix is this line where x is equal to positive 2. Alright, the focal width, remember, is the distance from one end of the parabola to the other end of the parabola that goes through the focus. So to find that focal width, we need to take the absolute value of 4 times p, and that gives us the focal width. So it's going to give us a negative 8, and then we take the absolute value to get a positive 8. And what that means literally is that this distance, this green line segment's distance, is equal to 8. You go up 4 top, down 4 bottom, and we get a distance of 8. Excuse me. And here I have all of my answers. Okay, let's move to the next problem. We want to find the parabolic equation with a directrix of y equals 2 and a focus of 0, negative 2. I think the easiest thing to do is to graph these, the directrix and the focus, and then try and understand the type of parabola that we're looking at, and then try and come up with the p-value. So I have a directrix at y equals 2. So that means I have this line, this horizontal line here, and this is the directrix, and I have a focus when x is 0 and y is negative 2. So here's our focus point here. And this visual gives me a pretty good understanding of what my parabola is going to do. Remember that the focus is within the cup of the parabola. So my parabola is going to be face down here. The directrix is in back of the vertex of the parabola. So because I have a parabola that's face down, I know I'm dealing with the equation x squared. I have x squared equals 4py that I'm dealing with. The only thing that I need to find to come up with the equation of this parabola is the p-value. What is the p-value? The p-value is going to be negative because we're faced towards the negative y direction. Remember, the p-value is the distance from the vertex to the focus point, and we see that we have a distance of 2 there. So because we're face down, p is going to be equal to a -2. And we simply need to plug in that p-value of -2 to come up with the equation of the parabola. We have x squared equals 4 times -2 times y, and that gives us x squared equals -8y. And that's it. That's the equation of our parabola. So we will also be looking at parabolas that are not that do not have the vertex centered at the origin. We're going to be looking at a parabola with a vertex other than 0, 0, and that means we're going to be dealing with the hk value. The h represents the x value of the vertex, the k represents the y value of the vertex. This is similar to the parabola in vertex form. So if we're dealing with a parabola that is on its side, we have a horizontal axis of symmetry, we're dealing with a parabola that has a y squared in it. If we're dealing with a parabola that has an axis of symmetry which is vertical, that means that the parabola is either faced up or down, and we're dealing with a parabola that has the x squared in it. So these are the two equations here that we're going to be dealing with when we have a parabola that is centered, that has a vertex other than 0, 0. You can use these definitions here to come up with the focus and the directrix with a parabola centered with a vertex at hk. However,